Locked-in syndrome is a condition that usually stems from damage to the lower part of the brain. So patients that have locked-in syndrome are fully cognizant, unaware. They can think just like you and I can. They have thoughts, they have feelings. They can feel pain generally throughout their body. They just don't have any voluntary muscle control.
People who have a stroke maybe, or they're in a car accident and then they have damage to that portion in their brain, or a degenerative muscle disease like ALS could induce a locked-in state.
So we made the eye tracker originally because a lot of them do have eye movement, but some of them don't. And if that's the case, then what can we do for them? Some of them can actually move their hands but can't move their eyes. Some of them can't do anything at all, and in that case, you can work with a therapist and maybe try to come up with some other yes-no communication device. And in that situation, you could literally have the therapist move the mouse and just look for some kind of recognition from the person. So that's the idea, is to try to make this as adaptable as possible for a syndrome that really encompasses a wide range of functionality.
Right now we're setting up a calibration. All that's required here is to make sure that both of her eyes are in view. Great, so now that it's in position, she's going to calibrate the eye key. So calibration consists of her looking at every square that's illuminated.
Ultimately, the idea is that if you refine this enough, this becomes something that you can deploy on like a really small scale on like netbooks and laptops. Anyone with a computer can use this kind of an algorithm.
Good. Now we're going to use the eye tracking based keyboard. So Hannah has the ability to look around, all around this keyboard, and select the bin or the letter that she's looking for. We started about Thanksgiving of last year. That's when our group came together, and we actually got our project assignment, what they wanted us to do. Since then, we've put in a fair amount of hours. I don't know, what do you guys think we average a week?
Anywhere from 4 to 10 a week. I mean, depending on the week and what has to get done.
4 to 10 a week per person.
Per person, yeah. Per person.
How do our calibration images look?
I don't know. All right, we had 2 circles.
Unfortunately, the mortality rate for individuals with locked-in syndrome is incredibly high. And one of the difficulties is that a lot of these patients, 90% of them don't survive more than 4 or 5 months. But because of requirements from insurance to get copay, eligibility requirements to get these devices or to get the high-end devices, which can cost up to $20,000, a lot of these patients can't get these devices for 6 or 7 months. So during the time when they could be recovering or they're teetering on whether they'll recover or not, they're trapped, and the best they have is maybe a board with letters printed on them that a speech therapist has to interpret. So the idea here is that we have a cheap alternative that somebody that really needs this device can get, so they can have some sort of communication, because these patients or these individuals are really in the most severe circumstances.
I think it was a really good experience. It was really good to have the chance to actually see what we've done here in terms of classwork and coursework, and actually put it to use to create a product rather, that somebody needs and wants and can really use every day.
What I loved is just the whole process, because when we first started and we were thinking about how we were going to do this, a lot of our ideas that we had, we didn't think were going to work at all. But then we basically taught ourselves what needed to be done, and we were surprised by all that we've accomplished from this.
It's really different for me. It's nice to be able to work on something macroscopic. I spend a lot of time in lab where you're working with chemicals and you can't really see the direct impact so much, but with this it's cool. We went from having an idea and now we have a product that works, so that's been a really neat experience.
Sweet.
Yeah, dude.
I think the coolest thing here is that there's nobody telling us how to do this or what has to be done. We were presented with a problem, and no one even said we had to use a computer to build an eye tracker. The problem was that when people are paralyzed, they can't communicate very well. How do you fix that? And we started with a plethora of different ideas, and we were able to boil it down and figure out what we think would work and not work. And we went through this process, but it was driven all by us. We decided what we wanted to do and what we didn't want to do. We justified all of it, and as long as we could justify it, we were able to make progress and really guide how this turned out on our own. So it's something we can take credit for, and our professors helped us and kind of guide us along the way, but they didn't make these decisions, we did, and I think that's really empowering and feeling.
This is the University of Rochester.